Jai Hind everyone. In our previous video, we have discussed that what are actually exponents and power. In this video, we will discuss about the properties or laws of exponents. So let's begin. As you can see, it is already written on board that the properties of exponents, basically there are these 8 properties for any rational number x upon y and k upon l. Okay, so first term here is rational number. You would be thinking that what are rational numbers actually? So rational numbers are actually any numbers which can be written in form of a upon b. Okay, which can be written in form of a upon b, where a and b could be integers, could be what? Integers, but b should not be equal to 0. So rational numbers are actually huge terms. Many numbers are rational numbers, like you can see that 2 is a rational number because it can be written as 2 upon 1. All the integers are already rational numbers because they have 1 as their denominator. Okay, 0 is also a rational number because 0 can be written as 0 upon 1. 2 by 3 is a rational number. Minus 6 upon 7 is a rational number. All the numbers here are rational numbers. Such more you can find out more examples. So it was just about a brief introduction about rational numbers. Now let's come back to our proposed topic, properties or laws of exponents. So what are laws of exponents? For any rational number x upon y and k upon l. Okay, I have taken for example two rational numbers x upon y and k upon l, and I have taken two positive integers a and b. On the basis of these, we will discuss the properties of exponent. First one is here, x upon y raised to the power a, when multiplied with the same number x upon y but raised to a different power b, then the result is actually the same base raised to the power of the sum of exponents. Okay, so how can we say that? As you can see here, let's have a look at example. It is actually saying that if it is saying it is 2 raised to the power 3 into 2 raised to the power 5. So we can actually write it as 2 raised to the power 3 plus 5, that is 2 raised to the power 8. Okay, why this happens? It is written 2 raised to the power 3. So it means if we expand this term, it can be written as 2 into 2 into 2. And if we expand this term, it can be written as, here the multiplication sign, and this term can be expanded as 2 into 2 into 2 into 2 into 2. Okay, it means if you count it, now here the 2 is multiplied 1, 2, 3, 4, 5, 6, 7, 8. 8 times. If we write it in exponential notation form, then 2 will be the base because 2 is multiplied with itself so many times, and as we discussed in our previous video, the number of times it is multiplied with itself is exponent. So 2 raised to the power 8 it can be written as. So hence it is proved that if two numbers have same bases but different exponents are multiplied, then their exponents are added. In the same way, if you look at the second property, if the same numbers having different exponents are divided, then their exponents are subtracted. How we do this? Suppose we are dividing 2 raised to the power 3 from 2 raised to the power 5 from 2 raised to the power 3. So it means that according to property, it can be written as 2 raised to the power 5 minus 3. It means 2 raised to the power 2. If we simplify the LHS, then it is 2 raised to the power 5 divided by 2 raised to the power 3. We know that when we convert the division sign into multiplication sign, the divisor is actually inversed. We write the reciprocal of divisor. So it can be written as 1 upon 2 raised to the power 3. Now let's expand this. Here the denominator is 1. So the multiplication is done numerator to numerator and denominator to denominator. So it can be written as 2 raised to the power 5 upon 2 raised to the power 3. Now let's expand this. 2 raised to the power 5 means 2 multiplied 5 times, and 2 raised to the power 3 means 2 multiplied 3 times. Now these 3's will cut these 3's. These 3 2's will cut these 3 2's. What is left? 2 2's are left. It can be written as 2 into 2. And when we write it in the exponential form, it is what? 2 raised to the power 2, which is same as our answer by the property. So it is clear that this property holds good for rational numbers. Hope you have understood the first two properties. Now let's come to the third property. Third property is actually saying that if two numbers have same exponent but the bases are different, then the result is actually the multiplication of the numbers raised to the same exponent. It means that if it is 2 raised to the power 3 into 3 raised to the power 3, so we can write it as 2 into 3 raised to the power 3. Okay? What will be the answer? 2 3's are 6. 6 raised to the power 3. Okay. Now let's see that how this answer comes. 2 raised to the power 3 can be written as 2 into 2 into 2, and 3 raised to the power 3 can be written as 3 into 3 into 3. Okay? As you know that using commutative property, we can multiply the numbers by shuffling them. So if I multiply this 2 with this 3, what I get? 6. In the same way, if I multiply this 2 with this 3, again I am getting 6. And on multiplying this 2 with this 3, I am getting the 6 again. It means 2 multiplied 3 times into 3 multiplied 3 times can be written as 6 multiplied 3 times. And in exponential notation, this can be written as 6 cubed. So hope you have understood that how this property actually works. Now let's come to the fourth one. Fourth property is also the same, just at the place of multiplication, it has been replaced with the division. That if two numbers have the same exponent and they are divided, then their result is their division raised to the same exponent. Now I am leaving this up to you to get it proved. Question number 5 is saying that any number having exponent 1 is actually the same number. Okay? So clearly that if you see any number having power 1 is actually the number itself. Let us prove fourth and sixth one similarly. Fourth one is fifth and sixth all together actually. Fifth one is saying any number having power 1 is the rational number itself, and any rational number raised to the power 0 is actually 1. Isn't it fascinating? that a number raised to the power 0 is not actually 0, it is 1. Let's try to prove this. In order to prove these two properties, 5th and 6th, I am taking help of a number. Suppose I am taking 9 raised to the power 4, 9 raised to the power 3, 9 raised to the power 2, 9 raised to the power 1, and 9 raised to the power 0. Do you see any pattern? Yes, the base is same, but the exponent is continuously decreasing by 1. It is 9 raised to the power 3, 4 minus 1, 3, 9 raised to the power 3. Here 9 raised to the power 2, 9 raised to the power 1. So the power is decreasing. Okay. 9 raised to the power 4, on expressing we write 9 multiplied with itself 4 times. In the same way, 9 multiplied with itself 3 times for 9 raised to the power 3, 9 raised to the power 1, I am not writing these two terms. If you see this pattern, from coming to 9 to the power 4 to 9 to the power 3, when we came from 9 raised to the power 4 to 9 raised to the power 3, what we actually did, if you look at the right part, we divided the RHS by the 9 itself. It means it was, for this what we did, we divided the 9 raised to the power 4 by 9, so that we can get 9 raised to the power 3. 9 will cancel, 1 9, and now 9 raised to the power 3 is left. In the same way, when we come from 9 raised to the power 3 to 9 raised to the power 2, we again divided this by the number 9, so that now we get 9 into 9, which is 9 raised to the power 2. In the same way, when we will come 9 raised to the power 1, we will divide this again by the number 9. What we actually get is 9 into 9 upon 9. What we get? 9. So 9 raised to the power 1 is 9. Let us write it in the same manner. 9 raised to the power 1 is 9. So hence it is proved that any rational number having power 1 is actually the rational number itself. It means that 50 power 1 is what? 50. 2 by 3 power 1 is 2 by 3 itself. Okay? Now let us prove the sixth one. Any rational number raised to the power 0 is 1. As you know that from coming 9 to the power 3 to 9 to the power 2 to 9 to the power 1, we divided it by 9. Again we will divide it by 9. If we want to change it from 9 raised to the power 1 to 9 raised to the power 0. On dividing 9 by 9, what you will get? Exactly, you won't get 0. 9 divided by 9 equals 1. So what we get the answer? 1. So any number, any rational number raised to the power 0 is 1. So 50 raised to the power 0 is 1. 2773 raised to the power 0 is 1. Doesn't matter how huge a number is, if you have raised it to the power 0 is 1. X raised to the power 0 equals 1. Any number raised to the power 0 is actually 1. So hope you have understood all these 6 properties. Now let's come to the 7th property. 7th property is saying that any rational number raised to the power a, and again we raise it to any other power b, then actually the result is the same number raised to the multiplication of those exponents. It means that if it is saying 2 raised to the power 2 raised to the power 3 can actually be written as 2 raised to the power 2 into 3. That is 2 raised to the power 6. How it happened? Let's analyze it. 2 raised to the power 2 raised to the power 3 means, if we look at this, 2 raised to the power 2 is multiplied 3 times. So we can write it as 2 raised to the power 2 into 2 raised to the power 2 into 2 raised to the power 2. Now, if you look at the first property, same bases, if they have different exponents, they are added. Okay, and same exponents also they are added. So what we will do is, we can write it as 2 it makes what? 2 raised to the power 6, which is our answer by property. Also, you can expand it again and get the solution. 2 raised to the power 2 can be written as 2 into 2. 2 raised to the power 2 again can be written as 2 into 2. And this 2 raised to the power 2 can again be written as 2 into 2. Now count it. 1, 2, 3, 4, 5, 6. So it is 2 raised to the power 6. Okay, easy. So any number, if it has different exponents, so these are added. Like 3 raised to the power 5 raised to the power 7 is actually 3 raised to the power 5 into 7. That is 3 raised to the power 35. Easy? Okay. Now let's come to our last property, that if the exponent is negative, that is minus 1. So actually it is its reciprocal. It means that if it is written 2 by 3 raised to the power minus 1 is actually 3 by 2. How? Okay, what we are doing actually is that, suppose I am multiplying 2 by 3, okay, 2 by 3, I am multiplying by 2 by 3 and also I am dividing it by the number 2 by 3, okay. If we multiply and divide the same number, then it doesn't make any effect, because 2 by 3 will cancel 2 by 3 and the answer is 1. So any number multiplied to 1 is the number itself. Okay. It is actually 2 by 3 raised to the power minus 1. Let's take a simple example first. Otherwise you will be perplexed that what is going on here. Here. I am taking 2 raised to the power 2 I have taken a lot of times. 7 raised to the power minus 1. Okay. So 7 raised to the power minus 1. I am multiplying it with 7 and also dividing it by 7. Any issue? No? 7, it has power 1, as you know. Any number, if it is itself only, it has actually power 1. Now 7 raised to the power minus 1 also have one denominator. We know that numerator multiplies to numerator, denominator multiplies to denominator. So 7 raised to the power minus 1 into 7 raised to the power 1 whole upon 1 into 7 raised to the power 1. Now, if the numbers have same base but different or same, when the base is same, then actually the exponents are added in case of multiplication. So we can write it as 7 raised to the power minus 1 plus 1 whole upon 1 into 7 power minus 1 is actually 7 itself. Now, minus 1 plus 1 gives us the number 0. So 7 raised to the power minus 1, which was already here for all the terms, is actually equal to 7 raised to the power 0 upon 7. What is the value of 7 raised to the power 0? We have studied by the 6th property, any number raised to the power 0 is 1. So it can be written as 1 upon 7. So actually 7 inverse is 1 upon 7. In the same way, the previous example we took, 2 by 3 power minus 1 is actually 3 upon 2. Okay, so now I hope you have understood all the properties. From the next video onwards we will begin exercise. Till then, bye bye, take care, Jai Hind.